Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. Moving on to the next question. Longest palindromic substring. So the problem number 5 which is given in Leetcode. So we'll see what is this longest palindromic substring and how to find. We'll see the logic. Given a string S, return the longest palindromic substring. So of course here some examples are also given. Anyway, we know about palindromic, right? What is a palindrome? So if you see in reverse, maybe the elements, if you take palindrome number means if you consider 141, okay, if you take it in reverse also the same number you have to get, that is palindromic number, okay, something like 2552, right? So that is a palindromic number, but here we are taking in terms of characters, which is about string. So what is palindromic string? So let us suppose we know MAM, so that these are palindromic strings, and of course we know one more good example is literal. If you see in reverse also the same. So that is about palindrome string. But what is this question is asking? So we have to find a longest palindromic substring. A string will be given as input. You have to find what is a longest palindromic substring. First of all, you have to get what are the palindromic strings, which are of course substrings in a string, and what is the longest one. So if you consider the base case, like every character is a palindrome itself. Let us say if I take a character A, if you see in reverse it is also A. So that means every character, every substring with length 1 is a palindrome in any string, right? Can I say? So once again, every substring of length 1 in a string is a palindrome. So here what we need to find is what is the longest one, means which is of the maximum length. Okay. So in this example you can see BAB is also is a palindromic substring, right? So of course ABA also is a valid answer. You have to get any one, right? Yeah. So what about this one, CBBD? Okay. Of course C simply BBD. All individually are palindromic of length 1, right? But what about length 2? Only BB you have. Okay. Is there any length with 3 which is also a palindrome? No. So that's why this is my answer, which is BB. Of course, if we take a simple character A, what about AC? Either A or C. Anyone can be a palindromic substring, right? So this is what we need to get it. So if you want, you can take more examples also. If I take A, B, B, C. So let us suppose if I take what is the longest palindrome here. So anyway, if one length each character is a palindrome, 2 length you can find BB is a palindrome, right? Of course it's a substring, it is asking, it's not a subsequence. There is a clear difference, I told you, no? So I'll let you know what is this difference between substring and subsequence in the next video lecture actually. So next question will be based on subsequence, you will find. Okay. So subsequence means, substring means there must follow continuous order, but whereas subsequent there is not required. Okay. Yeah, here BB is a substring which is also a palindrome of length 2. Is there any with length 2? No. So what is there any with length 3? Yes. So ABA. So now is there any other? So BAB is also there. Yes. So is there any length with 4? No. 5? No. Like this. So what is the longest one? It is, which is 3. So that must be find out. So this is a question, that is finding the longest palindromic substring. So what are the steps we have, how to get this answer? So anyway, first we'll see what is the naive approach. So what is the general approach we follow? How to get this longest palindromic substrings? Means first of all we need to find all the substrings. For each substring, check whether it is a palindrome or not, and whichever is the length with largest, that can be returned, right? So what is the complexity we will get in this? Of course, what is this naive approach means? First of all, we need to find all the substrings. Okay, let us suppose if I take this one CBBD as an example. So first of all the substrings means I can see C is a substring, CB and CBB, CBBD. Okay, and next starting with B, BB, next BBD, next starting with this B, starting with this B, BD is that, and the last one is D. So totally, so you will get, if there are n characters, I think you will get n into n plus 1 by 2 is our answer, right? So these many substrings you will get, which is of the complexity of n square, and for each one you have to find whether it's a palindrome or not. Again the complexity is n. So totally you will get the complexity is n cube, right? So this is the complexity you will get when you go for naive approach, which is of course a brute force, simply taking each substring and finding out. So what is the longest palindrome in this? You are checking everything. This is not, this is not, this is not, this is not, this is, sorry, this is yes. So this is yes, this is not, this is yes, this is not, this is yes. Out of this, what is the longest? BB will be your answer. So this is a naive approach. But we are going with the another approach, which is a dynamic one, using dynamic programming, where you will get the complexity of big O of n square only. Okay, not n cube, n square, you will get the answer. So how to do this? What is this dynamic programming approach for this longest palindromic substring? That we will see now. So here you can see we have to define an array which is two-dimensional array, where the values I can store only 2. That's why only 2 values, that is either 0 or 1, or else you can take true or false, whatever it may be. Okay, so 1 represents true, 0 represents false. So which is, that's why Boolean 2D array, two-dimensional array. Anyway, I have taken here, I have taken an example here. So how to proceed for this we will see. So now I have taken this string, where I'll take this one as an array, where indexes I'll take like this, starting with 0. So these are the rules which we need to follow. That means if for a of ij, so how to fill up this one? How to fill up this 2D table means a of ij is equals to 1 if s of I up till s of j is a palindrome, otherwise 0. Okay, we'll see those things, everything. Anyway, I have to take first here. So starting with 0, 1, 2, 3, 4, 5. Again here 0, 1, 2, 3, 4, 5. And I have to let us write the characters also. What are the characters we have here? B, C, D, D, C, A. Right? So here also I'll write B, C, D, D, C and A. Okay, yeah. Now after writing this one, we have to follow these rules. So first thing, so what are the rules, what things we need to fill up in this, and how to fill up and how to get the answer, we will see here. So starting with a of I is, those base cases are, if a of I, that means I indices are same, then directly true. What is the meaning of this one? When the indices, the values will be same, that means if I say a character, let us suppose 0 0 means only one character, 1 1 means only one character, right? A of 0 0, what is that character? B. A of 1 1, what is that character? C. A of 2 2, so the character is D. So that means each single character is always a palindrome, right? I told you, no? So single character is always palindrome, so that's why 1. Now one more base case, what is that? I comma I plus 1. Let us suppose if I take B and C, so can I say B and C, is it a palindrome? No. But if I say B and B, if I have, yes, I can say it is a palindrome. That means when this I, A of I and I plus 1, if both the characters are same, then I can result it as true, otherwise false. So that is what here. So if both are same, so it returns 1, right? Double equals to. If both are not same, it returns 0. That's it. So adjacency, that means 2 characters if you take. And now if you have more than 2 characters, then you can follow this formula. So this is what we have to check it out. So we'll start now. So initially base cases, I have to start from 0. It's 0 0, 1 1, everything should be 1, right? So 0 0, 1, 1 1, here 1, 2 2, here 1, 3 3, 4 4, 5. And remember, these parts we are not supposed to fill it up. Why? Because it's a substring always going forward, not coming back, right? Always going forward, not coming back. That means if I take BC as a substring, BCD as a substring, you cannot take CB as a substring, right? So this never we can check it out. DC as a substring, we can never check it out, right? Reverse. So that's why these things are empty, right? So this is initial, this check is over. Now we need to go for this one, I comma I plus 1. So when I is 0, what is I plus 1? 1. So 0 1. So 0 1, what you need to consider? 0 1 means, so BC. So here 0 you have B, here 1 you have C. BC not same, so that's why 0, right? Now 1 2, here 1 2, here C, here D. So that's why 0. Here D, here D, and here also D. Yes, 1. So both are same. Now here D and here C, right? DC continuous 3. So that's why 1. Now here C and here A. So that's why not equal. So that's why 0 here. And of course, sorry, this part, this is 0, right? So D and C, which is 0, right? Okay. So like this we need to fill it up. These two base cases are over. Now the thing, now we need to fill up with this. So this part where I value is 0 and J value is 2, right? 0 2. So J is 2, I equals 0, J equals 2. Now how to fill up this one means, which is equals to, no need to go further. So what is the meaning here is 0 to D. What is 0 to D? So 0 to 2. So what is 0 to 2? 0 to 2, B, C, D. Is it a palindromic substring? We are checking. So when you want to check these things, in between you may have some sort of the strings, right? Of course here you have only one character. So these things no need to check again. The result you can find it in the previous one. So that is what dynamic programming, right? Whenever you find, when you want to use dynamic programming concept, when there is overlapping subproblems, right? When there are overlapping subproblems, then you can use dynamic programming, or when you find optimal substructure, right? So the optimal value you have to get from the previous, right? So these two things you can go for dynamic programming. So that's what here you can happen. So 0 to 2, in order to get for A of ij, you are going to the previous one. What is that? I plus 1 comma j minus 1. So that means when you want to check for B to D, go forward and come back to the last one. So that will be what? I plus 1 means which is 1, 2 minus 1 means which is 1, 1 1. What is a 1 1 value? You can check it out, 1. If there is a 1, okay, this value is 1, and this is also should be equal. So 0, what is that? B, here C, are they equal? Sorry, here you are checking, no? B and D, are they equal? No. So directly it is 0. That means 1 and 0 is 0. So remember, first thing we need to check it out. First, these characters are matching. If then only you have to go for this one. That is a better thing, right? Now go for this one. So here C, here D. So checking with this C and D, is it a palindrome? Is it a palindrome? Definitely not. So you can see here C, here D, are they same? No. So keep it 0. Now here D, here C. So this one you are checking. So again 0. Now here D, here E. So 0 again. So like this we need to proceed. So for this one it is also over. Now checking for this one, 0 3. So checking with, starting with this one up till here, is this is a palindrome or not? So directly what we need to do, first thing, B and D, are they same? Not. So directly keep it 0, first thing. Anyway, this is 0 means 0 and something is 0. That's why I'm not checking this one. Here 1, C and C, yes, both are same. Can I write directly 1 here? No. Now you have to check it out, this one. So if this is also 1, then keep it 1, otherwise 0. Okay, what is the previous one? So that means here in this case, what is I value? 1, J value 4. So I plus 1. That means checking with this C and C. So whether it is a palindrome or not means inside you have to check it out whether this substring is a palindrome or not. So where you can find this one, you can see simply what is I plus 1, 2, what is j minus 1, 3. So 2, 3 you can see here you will find. So it is 1, so directly keep it 1. So first thing, these two characters should be matched, here C matching. Then you have to check it out, this cross one, mostly this cross one directly you have to check it out. If this is also 1, directly keep it 1. Now you can see this one, here D, here A, here D, here A, both are not matching, directly keep it 0. No need to check with this one. Now this part, so here B, here C, directly keep it 0. Now here C and A, no, so keep it 0. Okay, yeah. Now one more thing, and one more thing, last one is here B, here A, 0. So now we have to find what is the longest common substring, right? So where is that value? So we forgot to write. Actually, whenever you get the value as 1, then you have to keep track of the value that is maximum, a variable value maximum. We forgot to write. Anyway, I'll explain here how to write this max, which returns actually the value of the substring where it is there. Okay, length will be, you will get the length directly. Okay, so where you will get here is, so when initially you are getting 1 1 here, so anyway max is 1 here initially. Okay, now where the value is updating, if you go for the value next, so here you got the 1. Now you check it out, what is I value, what is j value. So that means you have to max is equals to simply you can write what is j minus I plus 1. Remember this point, what is the formula is j minus I plus 1. So in this case, what is the j value? 3. What is I value? 2. So 3 minus 2 plus 1, so which is the value is 2. So that means in this case you can see what is that, D and D, which is a palindromic substring of length 2. You can see, yeah, so max is 2. Now you can see in this line no other ones. Next, going with the three characters, here nowhere it is 1, so that's why no need to update. Here you can see, yes, here it is. So now we need to update for this. What is I value? 1. So I'll write here, so what is I value? In this case 1, and j value is 4. So now you can see j minus I plus 1, 4 minus 1 plus 1, which is equals to 4. So that means the maximum length is 4 here. So that means C to C. What is C to C? Here to here. So can I say this is a palindromic substring? Yes. So now the length is updated to 4. Now again, is there any 1 here? No. Here? No. Here? No. So finally the answer is 4. So that's why the answer is, the maximum value you can get here is 4 from this. Anyway, you can observe here, instead of here A, if you have here B, let us suppose. So what happens, you can see B, C, D, D, C, B, which is completely a palindromic string, right? So then you will get here as 1. So then you can see what happens, 5 minus 0 plus 1, which is 6. So complete substring. So that also you can try. So for this one the answer is 4. So which is the maximum length. So anyway, if you want to get what is that substring, so here you are getting, that's why what is that I value? 1. What is the j value? 4. So that's why substring of, anyway you can return in Java, you have a function, so substring from 1 to 4, which is your answer directly. So the length is 4. So like this we can consider and we can get the answer for longest palindromic substring. So this is as we are getting the values from always from bottom to top. So that's why it is, we call it as bottom up approach. And also you can see here why it is dynamic programming. All the subsequences we have, like optimal substructure, we got the answer. Overlapping sub problems, you can see whenever you want to find this one, you require this previous. Whenever you want to find this one, you require the previous. So that is what here which we require. So anyway, we have base cases, right? So this is what about dynamic programming. So you can write the code by using these sort of the cases, everything in any language. We can see another important problem. that is longest common subsequence in my next video lecture. Thank you.